Chapter 1, Section 1 of Honors Geometry, Understanding Points, Lines, and Planes. What we have to really do is we have to get back to the basics of Euclidean geometry. Now, when I say Euclidean geometry, that is a possessive term. It is Euclid's geometry. He created it. If he created it, he gets to set the rules. If we're going to study it, we have to follow those rules. So we have to start at the very bottom to see what Euclid is using to build his geometry. And as we go through the year, we're going to constantly be building upon previous content to look at new aspects of his geometry. So we start at the beginning with these things that are called undefined terms. Now, these undefined terms, they cannot be defined in terms of something else. All right? There's no real good analogy or metaphor. They are their own objects that he is defining, and we have to use his definition. We can't try and create a parallel to something else. Now, those first three undefined terms are a point, a line, and a plane. Now, you've probably heard these terms before in some context, and I bet you have a frame of reference of what's going on, but let's really get back to the fundamentals of what Euclid was talking about. A point names a location and has no size. So there's a point right there, in the air, just floating there. You can't see it. Has no size. It's invisible. But it does denote a particular location. Okay? And there's a point just over here kind of next to it. No size, you can't see it, it's invisible, but it denotes a different specific location. We name points with just an uppercase letter. Let's be really creative and say point P. Now the diagram, how we represent it. If I were to stand up here for the entire year and be like, okay, everyone name this point and tell me where it is, well, that'd be kind of difficult because it's invisible, it has no size, you can't see it. So we have to cheat a little bit. We have to create a visual that represents that point. And we use a dot. We call that dot point P. A line is a straight path that has no thickness and extends forever. Here's what that means, no thickness and extends forever. You also cannot see a line because it has zero width. All right? All that a line does is that it kind of represents a straight path. It can also be used to find distance. Just that one measurement, that one dimension. Now the diagram, if I were to draw a line, you wouldn't see it because a line has no thickness. It's invisible. But we cheat a little bit. We say, okay, from this specific location in space A to this specific location in space B, draw as straight a line as you can that connects them. So that's visually how we represent that line. A plane is a flat surface that has no thickness. So you could see a plane if you were looking at it from above or from below. You could see that flat surface. If you were to come right up with it, like hold a sheet of paper right up, okay, it would be even thinner than that sheet of paper. You wouldn't be able to see it. Now, we don't really have a good visual like shape for a plane, so we get really creative. And we can say plane ABC. To draw that, we kind of draw like a slanted rectangle that has a little bit of depth. Again, it's kind of this visual cue for our eyes to perceive, okay, there's that little bit of a slant, and our eyes kind of perceive that as depth. Now, points on the same line are co-linear. You know, co means together. When you live with a bunch of people, you habitate. You cohabit the same house with each other. Good English language lesson there. So collinear, points that are on the same line. Points, we don't exactly reinvent the wheel there. They're coplanar. They are on the same plane as each other. So these undefined terms are where Euclid starts his geometry. These are the essential building blocks with which we create everything else that we look at. So if you were to look at these diagrams and kind of see what they're asking you to do, in this diagram here, name 3 collinear points. All right? So we need 3 points that reside on the same line as each other. Well, we have this line right here. There's 3 points on that line, so we're going to list them. And when we list geometric objects, you just list them all out with their names, and you use a comma to separate them. So point K, comma, L, comma, M. Doesn't matter what order you put those points in right now, you're just listing those 3 points. Over here, name 4 coplanar points, so 4 points that lie in the same plane. You can take a look at that problem and then check my completed notes online to see how you did answering that. So now, moving on to some bigger and better objects, okay? Segments and rays. So a segment, and you'll usually hear me say line segment, just because that's kind of my default go-to for talking about these. A line segment is a part of a line. You kind of choose a beginning, and you choose an end on a line, then everything in between that beginning and end is the segment. All right, so the name, with the line, we have those arrows on the end, right? Well, with the segment is finite. It does not go on forever. So we remove the arrows. Just a finite segment, AB. And then this is a diagram of what that would look like. The beginning and the end that I talked about, we call those an endpoint or endpoints. Those are the points at the end of the line segment. And we'd name those, just like we would any points. You list the 2 points, point C at the end, point D at the other end, put a comma in between them because you're listing more than one geometric object. A ray starts at a location in space and then just goes off in some direction infinitely. All right? So you have one endpoint, and then the ray just goes in some direction. So if we have ray RS going from R through S, we have those 2 points, and then just a one-sided arrow. Now, because there's a direction involved, you can get kind of creative with this. Let's say it's going to the left, starting at R and going through S. Well, you could say SR, and then have that arrow notation pointing to the left. That's an option for you also. Truth be told, I'm pretty much going to talk about it like this, but that is also technically acceptable. And opposite rays are 2 rays that have a common endpoint and form a line. So they just go in the opposite direction of each other. So here, EF and then EG. We don't see this too often because they just form a line. Why wouldn't you just say line FG, okay? But if you really want to talk about opposite rays, you can have FEG right in there. So example 2, draw and label each of the following. Draw a segment with endpoints M and N. Draw a ray with endpoint M that contains N. Order here is very important. One of those points is the endpoint. The other one is on the ray. So you can try those drawings, take a look at my completed notes to see how you did. Now we're getting into a new vocab term, okay? When Euclid created his geometry, he set up a bunch of rules. And he called those rules, and this is from his book, The Elements, okay? This is like the oldest mathematical textbook in the world that's still used today. Your geometry textbook is just a variation of this, The Elements. And he talked about these things called postulates. All right, a postulate. Another word for that is an axiom. It's a statement that is true without proof. All right? You have to accept it as true. If you don't accept it as true, you can't play the game. If you're not going to follow Euclid's rules, you can't study Euclidean geometry. Okay? Here's an example of some postulates or axioms. Okay? In the English alphabet, A is the first letter. B is the second letter. C is the third, and so on. Well, why is A the first letter? Because it is. Why is B the second? Because it is. And if you don't want to follow those rules, then congratulations, you cannot speak English. Okay? That's just the way it is. You have to accept it. If you don't accept it, you're not going to do very well in your English classes. Okay? Why is 1 worth 1 unit? Why is 2 worth 2 units? Because that's the way it is. You have to accept those rules in order to play the game. So some of his postulates. Through any 2 points, there's exactly 1 line. So any 2 points are always collinear with each other. These points, right there, make those a little bigger. All right, you can draw a line through them. Now he says exactly. Draw another line through those 2 points that is not the same line as the one I've just drawn. You can't do it. Through any 3 non-collinear points, there's exactly 1 plane containing them. All right, let me get a little aid here. It says any 3 non-collinear points. Let me take these 3 fingers here and place that notepad on them. All right? Now, the minute I move this notepad, it detaches from one of the fingers. All right? Now, here's the thing. What if I had 3 collinear points? Well, look at this. Now, the notepad can shift around, and it's still touching all 3. So it has to be 3 non-collinear points. Contains exactly 1 plane. And if 2 points lie in a plane, then the line that contains them is also in that plane. It's kind of a transitive property thing. Well, you got 2 points in a plane. Any 2 points have exactly 1 line. Well, if the 2 points are in the plane, I guess the line is in the plane also. I already kind of spoke about this. 2 ways to identify the plane to the left. GHF, although I'll usually put the word plane out in front there, or a italicized cursive capital R. Usually we just use the 3 points. Intersections of lines and planes. It's kind of the last thing we're going to look at in this video. So if 2 lines intersect, then they intersect in exactly 1 point. 2 lines, where they intersect, exactly 1 point. There's no way for a line to curve back around because a line is a straight path. It doesn't have any bend or twist to it. So at this one brief moment, these 2 lines are like, hey, how you doing? And then they never see each other again. If 2 planes intersect, they intersect in exactly 1 line. So I draw a plane, draw another plane. All right, where they intersect, that crease right there, exactly one line. So you can take a look at example 3, these 3 drawings, take a look at them, see how they go, and then you can check my completed notes to see how you did with example 3.